Hey everyone, welcome to my channel. So in this video, I'll show you some of the different logic gates that we have. So let's get started. So here we have the basic gates like the NOT gate or a gate and gate, and then we have the universal gates that are NAND gate and NOR gate, and then the exclusive gates that are the XOR and XNOR. So let's see them one by one. So first we will have the NOT gate. So first we will see the symbol of this gate. So the symbol would be something like this. So you can also follow along with me if you want. The NOT gate is basically a single input gate. So the main function of the NOT gate is to invert the input. If we give 0 as the input, it will give 1 as the output, and if we give 1 in the input side, then it will give 0 as the output. So let's see the truth table for this. But before explaining you the truth table, let me show you some basic things which will help you to understand the truth table and how to draw the truth table as well. I will decide the combinations of the table, like how many combinations you will have. So you will decide the combinations with the help of this formula, that is 2 to the power of n, where n is the number of inputs. Suppose if we have the number of input as 1, then 2 to the power 1 will be 2. It means we will simply have two combinations like this, simply 0 and 1. If we have the number of inputs as 2, then the combination would be 2 to the power 2 will be equal to 4. Then we will have 4 combinations, something like this. How we will decide that what you will write here, like 0, 1, like this, how you will decide what you will enter here. So let me show you that also. So to decide the combinations, we have one simple formula, that is 8421 code. It means first you have to put 8 zeros like this. Then you simply need to put 4 zeros and 4 ones. And here you need to have 2 zeros and 2 ones alternate. And here you need to have alternate 0 and 1. So for a single input gate, if we have a single input gate, then the combination would be 0 and 1 simply this 0, simply this 0 and 1. And if we have 2 input, then we will have 4 combinations. Then we will simply have the combinations as these 4 combinations, like 0 0, 0 1, 1 0, and 1 1. Similarly, we will have 3 input, then you will have these combinations. Like if you have 3 inputs, then 2 to the power 3 would be 8. Then simply this combination. So this way you will decide the combinations, like where you will have zeros and where you will have 1. So now let's move on to our gates. So we have the NOT gate, as it is the one input gate. So we will have the truth table as simply X, which is the input, and Y, which is the output. And simply 0 and 1. If the input is 0, output will be 1. If the input is 1, output will be 0. Then we will have our second gate, which is the OR gate. So the symbol of this would be it will simply have two inputs, A and B, and simply the output as A plus B. This plus symbol does not mean the arithmetic plus. So this is the Boolean expression of OR gate. And let's have the truth table of this OR gate. So as the OR gate have two inputs, so the combinations would be 2 to the power 2, that would be 4. So it will have AB, the two inputs, and the output. And the combinations would be 0, 0, 0, 1, 1, 0, and 1, 1. And in the OR gate, if any of the input is high, that is 1, then the output will be 1. As here we have both the inputs low, so the output would be 0. And here we have one high input, so the output would be 1. Here also we have 1, 0. So we have one high input, so the output will be 1. And here also we have both the inputs as high, so the output will be 1. So let's move on to the next gate, that is the AND gate. So the symbol for this gate would be two inputs, A and B, and the output. It will be A into B. AND gate is also known as multiplication gate. And same for the other gates also. Simply y is equal to A bar. So we have our AND gate. Let's have the truth table for this as well. So the table would be again, as it is a two input gate, so we will have four combinations again. Again 0, 0, 0, 1, 1, 0, 1, 1. And these are the inputs and output. And the output is A into B. So 0 into 0 is 0. Again 0 into 1 is again 0. 1 into 0, 0. And 1 into 1 is 1. So the output is high only when both the inputs are high, that is A and B are 1. Now next move on to our universal gates. So why do we call these gates as universal gates? As with the help of these two gates, NAND and NOR, we can derive the other gates like these gates, the basic as well as the exclusive gates. So let's see these gates also. So first we will have the NAND gate. So the symbol for this gate would be And the NAND gate is basically the combination of NOT plus the AND gate. So to have the symbol, first simply draw the symbol of AND gate, as here we have the symbol of AND gate like this. So simply the symbol of AND gate and the NOT gate symbol here, as here we have, as it is a combination of NOT plus AND. So the inputs A and B, and again the output Y. This time the output of this would be A into B for AND gate for the first combination of this, and simply a bar. It means invert that. So this is the Boolean expression of this gate. So let's see the table for this gate as well. Here also we will have 4 combinations, as it is also a 2 input gate. So simply inputs A and B and output Y. Again 0 0 0 1 1 0 1 1. And to have this table, I will show you some trick, so only for your understanding. So you can drive the table of this NAND gate with the help of one trick, that is, so let's have the output here Y. So as it is the combination of and NOT gate, so do one thing. First write the output of the AND gate, as here we have the output of AND gate as 0 0 0 1. So simply write that and then invert that, as it is the combination of and NOT. So first write the output expression of AND gate, that is 0 0 0 1, and then simply invert that. So 0 1, again 0 would be 1, again 0 would be 1, and invert of 1 would be 0. And this part is only for your understanding. Please don't write this in your exams. The truth table is this much only, this A and B and the output. So now next move on to our next gate, that is the NOR gate. So the symbol would be, and this is the combination of OR gate plus NOT gate. So the symbol would be the symbol of OR gate and simply the symbol of NOT gate, and 2 inputs A and B, and the Boolean expression for this would be simply OR operation A plus B, and then the NOT operation, that is the bar. Simply invert that. Then we can have the table for this. Again 2 inputs A and B with combinations as 0 0 0 1 1 0, and again 1 1. And here also the output. First, again write the output of OR gate, that is 0 1 1 1. So 0, 1, 1, 1. This is the output of OR gate. So first write, as it is the combination of OR plus NOT. So first simply write the output of OR gate and then use the NOT operation, that is invert these values. Like 0 would be 1, 1 would be 0, again 1 would be 0, then again 0. Now let's move on to our next gate, that are the exclusive gates like XOR and XNOR. Now why do we call these as exclusive gates? Because their output depends on exclusive comparison of inputs. What do you mean by exclusive comparisons? It means for XOR, output will be only one when both the input will be different. And for XNOR, the output will be one only when both the inputs are same. So let me write it down. So for exclusive gates, their output depends on exclusive comparison of inputs. So for XOR, the output will be one when the inputs are different, and for XNOR, the output will be one when inputs are same. So let's first have the XOR gate. So the symbol for this gate would be the symbol of OR gate, then simply a line here like this. Then again it is a two input gate, so A and B. And this time the Boolean expression for this would be simply A bar B plus A B bar. This is also equal to A, simply this symbol. This we call it as A XOR B. Now let's draw the table for this. Then again it is a two input gate. So A, B, four combinations again, 0, 0, 0, 1, 1, 0, and 1, 1. So as we have discussed, for XOR, output will be 1 when the inputs are different. So here we have different inputs like 0, 1, 1, 0. So the output would be 1, 1 for this. Now we have our last gate, that is XNOR. So the symbol for this would be simply the symbol of NOR gate and again a dash, maybe a line like this, with two inputs as A and B, and the output this time simply it is represented as A XNOR B, something like this, and it is also equal to A into B plus A bar into B bar. Now let's have the table for this as well. Simply a two input gate. So again the four combinations. And this time, as we had discussed, that for XNOR, output will be 1 when the inputs are same. So here we have same inputs. So here our output will be 1. And for the other cases, our output would be 0. So yes, these were the basic logic gates that we have. So hope you understood about these gates in a much better way. So see you all in the next one.